Well. Thank you for clicking on. We're back here in Lopezlandia. Let's get started. Ooh, do you get what it's saying here? O over H, Feld. It's an old show. Hopefully you get it. Let me know in the chat later if you got it. All right, today we're going to work on section 5.1 using trig identities. This is going to be very important. It's going to be some of the stuff that we did in the past that'll come back, and then we're going to add some new identities as well. All right, the objective. Students will learn how to identify trigonometric identities, simplify trigonometric expressions using trig identities. All right, this next slide is muy importante, very important. You have to copy it down, please. Make sure that notebook, pen, pencil, calculator is out. All right, and here we go. Fundamental trigonometric identities. I'm also going to have a PDF on Schoology for this, but copy it down. The sooner you become comfortable, the better life will be. Reciprocal identities. We've talked about these already. Cosecant theta, we know it's 1 over sine. Secant theta, we know that's 1 over cosine, cotangent, etc. Tangent and cotangent identities, we know that tangent is the same thing as sine over cosine. Cotangent is cosine over sine. Don't forget about those. Now we have some new identities. Pythagorean identity. So sine squared theta plus cosine squared theta is equal to 1. We also have 1 plus tangent squared theta is equal to secant squared theta. And we have 1 plus cotangent squared theta is equal to cosecant squared theta. Some other identities we've kind of seen already and played with. Cofunction identities, we have a sine of pi over 2 minus theta is equal to cosine theta, etc. I won't read those out to you anymore. And then you have your negative angle identities. Make sure you pause here, copy everything. The ones that you're going to see most often will be these right here. Those are the ones you're going to see most often. Again, get comfortable with them. The sooner you memorize them, the better life will get, and the faster things will make sense to you as we're working on them. So remember the proofs that we did back in the day in geometry land? Well, we're going to do some sort of type of proof here as well using these identities, okay? All right, get those juices going. Here we go. All right, so for this one, we have, copy it down. Using the Pythagorean identities, find each trig function. All right. So they gave us cosine squared x. What they want us to do is to figure out which trig identity I'm going to need to use in order to prove cosine squared x or theta. Same deal. All right, if we look here, we have 3 Pythagorean identities. The one that I'm going to look at will be this one because this is the one that has cosine squared theta. Okay, and we're going to have it here. The idea here is to get cosine squared theta or x by itself. So if I look here, I notice that cosine squared x is being added to sine squared x, and that's equal to 1. Get rid of that sine squared. Get rid of it by subtracting it. Whatever we do to one side, you got to do it to the other side. What is this going to look like? I'm glad you asked. There you go. It should look like that. So now cosine squared x is equal to 1 minus sine squared x. Okay? Okay. Letter B. Now we have tangent squared x. Again, we're looking at my Pythagorean identities. Which one has tangent in it? Boom. This middle one, right? Okay, so that's the one we're going to play with now. Now what we want to do again is we want to write it down, and then we want to have tangent squared x by itself. Okay, so I see that it's being added to 1. Go ahead and subtract the uno from each side. What is that going to look like? It's going to look like this. Tangent squared x is equal to secant squared x minus 1. So all we're doing is manipulating our identities to have either tangent squared x by itself or cosine squared x by itself. All right, let's continue. All right, let's try another one. All right, copy that. Again, we're going to use the Pythagorean triples. Here we go. Now we have sine squared x. So again, there goes my triples there. And you want to decide which identity will be the best one to use here. Again, I would use the top one, and here we go. So the goal here again is to have sine squared theta or x by itself. Again, I want to now subtract the cosine from each side. And then that'll get me to sine squared x by itself. So what does that look like for us? We have that. So now we have sine squared x is equal to 1 minus cosine squared x. Let's try another. Ooh, now we got cotangent. All right, so cotangent, which identity am I going to use? Boom, I see the bottom one. We want cotangent by itself, so I'm writing down the identity. Again, now you want to subtract the 1 from each side, and when you do that, we should end up with cotangent squared x is equal to cosecant squared x minus 1. All right, box it up. Hopefully this is not too bad. All right, pencils down. Do not write this. Just watch, please. We're going to take a little trip to the past. Bum, bum, bum. All right, remember back in the day when we had problems like this? And you were asked to simplify and you had to factor out stuff in order to simplify. So here we had to factor out an 8 and then we were left with 4 minus x. On the bottom, you would notice that this is differences of two perfect squares. So you factored those out. You had 4 plus x times 4 minus x. And then you notice that you were able to cancel out stuff, top and bottom. And then you were able to write what you had left, which is 8 over 4 plus x, and that was already simplified. You couldn't do a single thing after that. Okay, wonderful. I'm glad this is coming back. Now, the reason why we're going to do this is because we're going to be incorporating the trig identities. And so the factoring business that we did algebraically will be coming back into play. Notice how similar these two problems are. Again, you have the 32 on each side. You have the minus 8 cosine x, and you have 16 minus x squared. Now you have 16 minus cosine squared x. Very, very similar. So just like with the previous one, you would want to factor out whatever you had in common. Here I factored out an 8, so I was left with 4 minus cosine x. In the denominator, I noticed that this was also differences of two perfect squares here. And so I was able to put it in that special pattern there. Just like in the past, cancel out whatever you have in common in the numerator and denominator. And so your final answer here would be 8 over 4 plus cosine x. Beautiful. All right. Let's do another pencils down. Again, you're just watching. So here we're going to factor this bad boy out. You want to look at letter A and see what do you think you're able to factor? A number, a trig, function, something. In this case, I'm going to say you can factor out a 2. And here we're going to have 2 minus 3 sine x, and we're going to have 2 plus sine x. Okay, where do we get this? Wonderful. Let me do some work over here. Un minuto, por favor. All right, so this is where it came from. I factored out the 2 first, and we were left with 4 minus 9 sine squared x. Again, inside these parentheses, you should see that this is differences of two perfect squares. That's why I was able to factor it into these this pattern here. All right, now here we have 3 cotangent squared x plus 2 cotangent x. All right, this is when you had your polynomial, your trinomial, remember? This is similar to that. Okay, sorry guys. There we go. All right, so when you factor it out, here you would have 3 cotangent x plus 8 times cotangent x minus 2. We'll do some more in the homework, okay? Let's continue. We're going to go ahead and simplify this. All right, in order to simplify, you want to think about what makes tangent? Okay, if you refer back to that page where I had you copy down the identities, you should recall that tangent is the same thing as sine over cosine. So that's how I'm going to rewrite it. I'm just going to rewrite it in that manner. This will allow me to simplify, and then times cosine, which we had here. So remember, if you go like that, you have a fraction there. Remember, you could cancel those out, and you should be left with just sine of x. Let's try another, please. You want to simplify this expression as well. So you have cosine squared theta over 1 minus sine theta. All right, you want to look at all of those identities I gave you. On the top, that cosine squared theta should ring a bell. You should be thinking of those Pythagorean identities. So let me show you the one that it actually pertains to, or the one you should be using, which is that one there. Okay, so I rewrote it. Notice that I have 1 minus sine squared theta. All right, if we look at the Pythagorean identity here, all right, so we want to get cosine by itself. So what I actually did was I subtracted the sine squared theta on each side, and that's how we got that right here. Okay, now another thing you should notice is that this is differences of two perfect square. The number 1 is a perfect square, 1 times 1. Sine squared is a perfect square, sine times sine, right? So that means I could factor this out now using our special pattern that we did in other examples. So that's how I end up with 1 minus sine theta times 1 plus sine theta over 1 minus sine theta. Again, I'm looking for things that I could cancel out. Boom, bye. What do I have left? And just that. Let's try another one. All right, here we go. Copy this one down. We have secant theta times 1 minus sine squared theta. All right, the 1 minus sine squared theta, this is coming from the Pythagorean triple. Remember, sine squared theta plus cosine squared theta is equal to 1. Okay, think about what secant is. Remember, that is a reciprocal, right? So it's a reciprocal, that's 1 over cosine. Yes, yes, yes. All right, so let me rewrite this. So now we have 1 over cosine theta, and instead of 1 minus sine squared theta, this is coming from me manipulating the Pythagorean identity. So that's how I got cosine squared theta. Again, make it into a fraction. Boom. And we should end up with cosine squared theta over cosine. You could cancel out something here. This is cosine times cosine, right? So we will be left with just cosine when you cancel out. Let's try another. Copy this one down. Okay, we have tangent plus cotangent. We have tangent plus cotangent in the parentheses, and we have that being multiplied to sine theta and cosine theta. It is not sine squared theta. It is not cosine squared theta. So be careful with that. They are not squared. Now, what I would focus on is inside the parentheses, tangent theta, cotangent. What's another way of writing down sine? What's another way of writing down tangent? It would be sine over cosine. What's another way of writing cotangent? It would be cosine over sine. So that's how I'm going to change it. All right, we know distributive property, right? So we're going to be multiplying the sine theta, cosine theta into everything inside the parentheses. Here we go. So we end up with sine squared theta times cosine, yes, over cosine theta. And then we have sine theta times cosine squared theta over sine. Okay, we're going to have to deal with this a little more. Oh. Okay, so if I look here, I will notice that in this fraction, I'm able to get rid of the cosines. Here, I'm able to get rid of the sines. What do we have left? We have sine squared theta plus cosine squared theta. That's one of our Pythagorean identities. That's always equal to 1. So my answer here is uno. Let's try another. Dun, dun, dun. Okay. We need to factor this. This is going to be a little weird. All right, so we have cosecant squared x plus cotangent x minus 3. I can't really factor anything out until everything is the same, meaning they're both cosecant or they're both cotangents, okay? So I need to play with one of the identities. And the identity that pops up will be this one here. All right, what does this tell us? This tells us that cosecant squared is the same thing as all of this. So I'm going to substitute. So instead of cosecant squared x, we're going to rewrite it as 1 plus cotangent x minus 3. So this part right here is the same thing as what we have there. And we just substituted the cosecant squared for what I had in the identity. Okay? All right, I see some like terms. I see the uno, positive 1. I see the minus 3. Collect them. When we collect them, simplify, we get cotangent x minus cotangent squared x minus cotangent x minus 2. Okay, remember when we used to do the magic x? Yeah. And we had our little triple. We had an A, we had a B, and we had a C. A times B, bring down the C. All right, my coefficient here is uno. Yeah. So that's going to be a negative 2. And you have a coefficient of a negative 1. So these are going to be 2 and 1. That's where it's coming from. And you have different signs. So negative 2, positive 1. So factored form will look like this. Cotangent x minus 2 times cotangent x plus 1. Okay? Now it's factored. Boom. We are done. All right. See you later.